Welcome to the Computer Network series. Today's objective is to understand and learn medium access control. Imagine four computers attempting simultaneous transmission on the same channel. What will happen? Yes, data collision, loss of packets, even a total chaos. Fine. How should the network resolve this? The secret lies in medium access control. So what is this MAC or the medium access control? It's a sublayer of the data link layer. As we have already discussed, data link layer is divided into two sublayers. One is medium access control and the other one is the logical link control. So this medium access control or MAC is a sublayer of the data link layer that controls access to a shared communication medium. The primary responsibility of the MAC is to decide which device to transmit at the time, when can it transmit, and how to resolve collisions. According to the textbooks, authors classify MAC protocols into two broad categories. Number one is controlled access and then number two is contention-based access. This session concentrates on controlled access. There are three types of controlled access. One, polling. Number two, reservation protocol. Number three is token passing mechanisms. Moving on, first up is polling. Polling is a controlled access protocol in which a primary station or sometimes a central coordinator asks each device one by one whether it has data to send. Look at the picture. The primary station asks PC1 whether you have data to send. It says no. Then it asks PC2, you have data to send? It says no. Now it is asking PC3, you have data? It says yes, I have data. Now PC3 is given permission to transmit, access the shared communication channel. This process repeats. So only the device that receives permission can transmit. So the primary station is the controller who manages everything in the network. Why polling prevents collision? Only one station is allowed to transmit at a time. Unlike contention-based protocols, devices never transmit without permission. Always permission is granted for transmission here. Listing the advantages of polling. Number one, no collision. Number two, all devices are given fair access. It is also simple to implement and understand, predictable communication, and this is suitable for real-time and industrial systems. On the downside, this has a lot of disadvantages. Like if the central coordinator or the primary station fails, what happens? The total network stops. Again, polling overhead increases when the network scales, and a lot of time is being wasted polling devices that has no data. Polling is mainly used in industrial automation, SCADA systems, master-slave communication systems, PLC networks, and embedded control systems. Moving on is the reservation protocol. Reservation is a controlled access protocol in which stations reserve transmission slots before sending data. Only stations with reservations are allowed to transmit. Look at the working principle of the reservation-based communication protocol. The reservation bitmap period is set. PC1, the bit is 1, meaning it needs to send. It's allowed to send then. PC2 0, PC3 1, PC4 0. So the reservation bitmap looks like 1010. And look at phase 2, the data transmission phase. PC1 is sending data to PC3. Fine. Whereas PC2 and PC4 remains silent. This is the working principle of a reservation protocol. Basically, reservation slots are announced. Each station indicates whether it wants to transmit. A transmission schedule is prepared and the reservation station transmits strictly in that order. Listing out the advantages of reservation protocols, it's again collision free. Fair access is possible, efficient when many stations have data. It is quite efficient compared to polling, and a predictable amount of delay is there. Talking about the disadvantages, reservation phases also introduce a lot of overheads, and quite an amount of bandwidth is reserved for the stations that do not transmit. So these bandwidths are wasted and it is not very efficient for lighter traffic. The applications include satellite communications, wireless sensor networks, TDMA based systems, and industrial communications. Moving on to the last is the token passing mechanism. A special control frame called the token is circulated continuously in the network. Only the station holding the token can transmit the data. Look at the example. If PCB wants to send data to some devices in the network, it has to first acquire the token. After acquiring the token, it sends the data to the destination machine. The destination machine receives the token, and then the token is being released by the sender. So this is the process. Token circulates throughout the network. A station with data captures the free token. Station transmits the data. Destination receives the data, and the station releases the token. Fine. The important rule to keep in mind while learning token passing mechanism is that only one token exists. Only the token holder can transmit. After transmission, definitely the token has to be released. What are the advantages of this mechanism? No collision, again fair access, there is a predictable delay. Even under heavy load, this token passing mechanism is efficient. Talking about the disadvantages, token loss can stop the total communication in the network, and management of such token is quite complex. The ring failure affects communication, the whole communication sometimes. This token passing mechanism, is found in IEEE 802.5, FTTI, and in industrial automation. Any doubts, post it in the comment section. I'll be happy to explain. Thank you. Happy learning.